estimate plasma osmolarity or osmolality. And I've got some of Mr. Good's numbers here. Let's just look at the sodium for right now. The month previous, it was 140, which is about normal. And the sodium went up to 157. Remember, he had an issue. He got dehydrated, possibly. Okay. Whereas we can't be entirely quantitative here, it's kind of a no-brainer, isn't it? I mean, you would bet any amount of money that his osmolarity, value for osmolarity is increased. His sodium is a pretty good indicator of that. Maybe we don't know exactly how much, but we know it's certainly gone up, and it's certainly gone up a lot. So sodium is one way of kind of guesstimating osmolarity. So what's used clinically? Na. So sodium's usually 140, right? So 2 sodiums, it's always got to have a negative or an anion with it. So if you double that, it's usually what, 280? Plus, and there's a formula there which you do not need to remember. You will see it many times. I think you need to understand how it's derived, but you do not need to remember this. I will never ask you a question and expect you to remember this formulation. So it's glucose over 18 and BUN over 2.8. Okay. So all these are measured in milligrams per deciliter, and this is just a conversion to moles. Okay, that's all that is. So in other words, this is moles, this is now moles, and this is moles. And pretty much, that's usually 5 plus 5. So we've made an estimate which fortuitously is pretty close to what we'd get if we measured it. We can measure it by depression of freezing point. We can take a plasma sample. We can stick it in a machine that freezes it, and you can determine at what temperature it freezes, and that's how you measure osmolarity. It's not actually a sophisticated test, but you can make this estimate, and it comes out with a value which is pretty darn close to what you would measure. And so, you know, medicine does this a lot. They come up with approximations that just happen to work out. So it's kind of useful in that regard. But beyond that, any particular reason why we decided to add we could have added potassium, we could have added something else or whatever. Why in our estimate of plasma osmolarity did we use glucose and BUN? Okay, it's a tough question, huh? So, yes, ma'am.
Do those have the highest osmotic index in terms of making water?
No, the osmotic effect is basically 5 and 5. But remember, you guys are medical students. One day you'll be doctors. And one day, some of these things might be perturbed. And guess what? There are an awful lot of sick people that don't have a glucose that's equal to 5. And there are an awful lot of sick people that don't have a BUN, blood urea nitrogen, that's equal to 5. And so there are certain conditions where those values may go up and you can kind of plug it into to the osmolarity. And it's real osmolarity, so it's useful in that regard. Got it? Good. Oh, and so going further down, okay, let's talk about the osmolarity gap or the osmolar gap. Because this is used clinically too. So, if you estimate the plasma osmolarity at 290, you would expect that probably if you measured my osmolarity, it would be 290. What would you say if we took patient X and we made this estimation, and now we measured the osmolarity at 340? What does that tell you? Before I say no, I want to just make sure that no's a good answer. Definitely a good answer. No, it's real. Okay, let me tell you it's real. I mean, I'm going to tell you that we measured this and it's real, and this estimate is garbage. I know it's Friday afternoon. Yes, sir. Absolutely. There is something else. You're good? Did you have lunch? Did you have that pizza? Hey, you guys have got to make sure you eat all this, because if you don't eat it, guess who has to eat it? And do I really need any more? No. Okay, so yeah, and there are a number of things that it might be. Some of the more common, like alcohol. If you drink alcohol, it would add to the osmolarity, and you wouldn't get it on the estimate. Antifreeze, ethylene glycol, sometimes hyperlipidemia. Okay, so there are a bunch of things that if you're a clinician and you get this blood work and you say, something's not quite right, let's measure the osmolarity. When you measure the osmolarity and you get something like this, it gives you kind of a clue as to what else you might be looking for. Okay? Yes, sir.
But would you need to know that those three main indicators are correct?
Yes, so the question is, would you need to know that the sodium, the glucose, and the BUN are normal before you make that conclusion? And yes, that's what I already did. Because when the patient came in, we went and got blood work anyway. It's pretty routine that you're going to get some blood work. And most blood work has these values. In fact, if you look at Mr. Good's values, is glucose there? Yeah. So, I mean, actually, this is an incomplete list of what you get on a blood chemistry, but you would certainly get, it's got creatinine, BUN, yes, glucose, yes, sodium, yes. So you would pretty much routinely have those values.
So if you have a patient whose osmolarity is like 340, like super high like that,
Mm-hmm.
would the two options be either they're dehydrated or they've added something else to the, or
So the question is it possible that this person could just be dehydrated?
I mean, are
And it's
there
kind of the same question. And
two scenarios that would cause that? Is dehydration or adding?
I'm thinking, I'm trying to think how dehydration could cause that.
I was just thinking less water in the solution.
If I come up with something different, I'll let you know. But I cannot imagine how that would be dehydration. But I'm not seeing that that could be indicative of dehydration,
Yeah.
okay?
Okay.
So I mean, I suppose you could still be dehydrated, but if you look at these numbers, you wouldn't be thinking dehydration.
I was just curious because